Hey everyone, I hope you all had a great conference so far. Thank you for joining me to talk about API mashups and how to combine APIs using GraphQL schema stitching. First, a word about myself. My name is Rouven. I'm a developer evangelist. I love APIs and I love cake. You can find me later at the cake place. If I'm not eating cake and not coding, I'm probably running to the streets of Berlin, where I live. I mostly run so I can eat more cake. So I don't do it out of pleasure, I do it out of necessity. I work for a startup called Contentful. What we do is we have a content infrastructure that allows you to separate your content management needs completely from your application stack. I'm not going to talk about this any further. If you're interested, please come up to me afterwards. I also have really cool socks that I would love to give to you. So, APIs. APIs are awesome. I'm preaching to the choir here. Most of us are developers. And when I explain APIs to new developers, or people who aren't developers, I like to say they're Legos. They're tiny building blocks that I can put together to something bigger. I might have to use some glue if I'm building a really big model, but the individual pieces contribute a lot to it. And the tiny little black boxes just do what I tell them to do. And developers love APIs. If you look what the current hotness, what the current trend in APIs is, the topic that comes up again and again is GraphQL. I want to give you a very short introduction to GraphQL because it's necessary to understand the rest of the talk. But the purpose of this talk is not to explain GraphQL as a whole, but just one specific use case for it. So first, why do people like to use GraphQL? Well, it has a strongly typed schema, unlike a RESTful API where I don't really know what data to get unless I have a spec for it. That schema is also introspectable, so I can reason about my API programmatically, even if it's an API I've never touched before. I can specify exactly what data I want and get just that data. And I can get all the data I want with just one API request. So I don't have to go back and make multiple requests to one API just to get all the data I want. And I think this is the reason why it's become so popular, it enables front-end driven data selection. It really empowers people working on the front interface, whether it's a mobile app or a web app, to have much more control over the data than ever before. And last but not least, and this is the reason why I'm talking to you today, it's composable. I can take multiple GraphQL APIs and combine them into a unified API. So if you, in your project, at your company, in your team want to start using GraphQL, you might have a conversation like this one that's supposedly happened at Airbnb. GraphQL is very scary for backend engineers like me because we don't think front-end developers know how databases work. And we don't trust you with databases. We just think you're going to bring everything down. So that's terrifying to us. But front-end developers think it's amazing. Folks like me just think it's really, really terrifying. So there are pitfalls here. GraphQL is not an easy technology. It's not just something you just hash over your existing API and you're in magic unicorn fairyland. It's actually a hard amount of work to get it work reliably. But what it unlocks is really, really powerful. And in the past years, since it's been developed by Facebook, it has grown a lot in popularity. And you now have many public and private APIs that make use of GraphQL for an easier development experience, including, and this is relevant to you all since you're here, GitHub's API v4 is completely based on GraphQL. So I want to give you a really quick example what goes into a GraphQL API. The core part of every GraphQL API is its schema. This is a tiny excerpt from the GitHub's GraphQL API. It's the type repository that implements an interface called Node and some of the properties you have on that interface. You see it has an owner, which is another object type called repository owner. The bang at the end means it's never null, it's always defined. It also has a URL as a connection to the stargazers. Next, I'm going to write a query. This is what I write to access the GitHub API. And I say, for the repository Contentful, in the organization Contentful, with the name contentful.js, which is our JavaScript SDK, I want to get the following information. I want to know what is the URL to access the repository. I want to know how many Stargazers are there. And I want to know in which organization does it exist. And what I get back is a JSON object. Now, if you look closely, you see that the structure of the JSON object matches exactly the structure of my query. So even if it's an API I've never touched before, if I just look at the query that somebody has written, I can already reason about the data the API will return to me without having to read any sort of documentation, just by looking at the code right in front of me. That becomes really powerful when you're working with APIs that are unfamiliar to you. So how do I write a GraphQL API? Let's write a hello world together. First, I'm going to import Apollo server. Apollo has released a lot of great tooling around GraphQL, and I'm using it throughout this talk. Apollo server is the very basic machinery to just set up a server that responds to GraphQL queries. First, I always have to write a schema. In this case, the schema contains just one query with the name hello that is going to return a string. Now, with a query, with a schema, I've only defined what's possible. I still need to write the code that actually responds to any incoming GraphQL query. For that, I write a resolver. For every query, for every object type, you write a resolver function that you pass to Apollo server that returns the data requested by the user. In this case, it's very easy. I just need to write a resolver for hello that returns a string. So that looks like this. And now I simply start Apollo server. And if I access this to a GraphQL client, again, I can see my schema. I can introspect my schema. I have a query that simply queries hello. And I get the word world back, which is a string, so it matches the schema. And again, the result matches exactly the structure of the query. So that's how simple it is to start with a GraphQL API. Now, let's get back to talking about our little Legos. We mentioned before, developers love APIs. Well, how much do developers love APIs? That's the question. Answer is a lot. Apps built today, 50% have 2 to 5 APIs in use. 9% use more than 25 APIs, one app. And I didn't make this up, I have a source on this data. That's a lot of Legos. And anybody who's a parent here has probably stepped on some Legos before and knows it's really painful when they're not in the right place. So with this many APIs, what do you need to know about them? Well, you need to know which API holds which data. If I want to render a view, I need to know which APIs do I have to query for it. How do I authenticate against each of these API? How do I get the necessary access permissions? And crucially, which fields in my API responses indicate a reference, a foreign key in database speak, to another API? And then how do I find that API? How do I resolve that? With 25 APIs in a project, that's a lot of complexity. And knowing all of this is quickly a Herculean task. And GraphQL makes some of that easier already. Even if all your APIs are using GraphQL, discovering how APIs work and what data is available becomes a lot easier. But the real power starts somewhere else. And the question that I ask myself is, what if we had just one API for all the data I need for a project? And what if Legos are the wrong metaphor for describing APIs? What if we could treat them like music? Who here has heard of mashups before? Musical mashups. All right, most of you? Good half. All right. A musical mashup was really big in the 70s, 80s. It's a song that's created by blending two existing songs together. I could take the lyrics from one track, the singing, and take the tunes from another track, for example. And a great mashup will be a good song in itself, but it will also leave the two songs that made that mashup possible recognizable. So if you hear it for the first time and you don't know the parts, you're going to think like, oh yeah, nice tune. But if you actually know the parts, it's going to be much more amazing. Let me give you an example. you might have some indie rock music, which is supposed to be playing right now. Can somebody from the tech see if that's on your end or on my end? Ah, now it works. All right. So you might have some indie rock music. And you might have an electronic track. And they're both fine pieces on their own. But what can we do by blending them together? Well, we get a great mashup. And if you listen to the song, you will still hear both of the individual songs. But if you just listen to it as the first time, you would not see it's a blending of two other songs. So let me give you an example how we can use this concept and apply it to APIs. At Contentful, we have a lot of open source projects. In fact, just our main Contentful GitHub organization has over 100 open source repositories. And it's starting to be really hard to keep track of them. What we need is a dashboard that gives me an overview of what's happening in our open source ecosystem. I want to pull that information from GitHub, because manually maintaining data is lame. I want to store some metadata in Contentful. And I also want to involve other services. For example, Travis CI already knows whether the tests succeed for this given project or not. I don't need to replicate that somewhere else. So first thing I did is I store all the data that GitHub doesn't know about my projects in Contentful. I can model my own data there. So I've modeled a repository, a team, a group, a department. So I'm just containing the information which repository is owned by which team in Contentful. And now I have these two APIs. I have GitHub, the indie rock band of open source. And I have Contentful, the Berlin-style electronic startup. But what I want is I want to have a unified version of this data. And that's my stitching proxy. So let's take it step by step, and let me explain you how I built the stitching proxy that meshes up these two data sources. Step one, I need to link up to a remote schema. To create a remote schema, I need to configure an HTTP link. The HTTP link simply goes to GitHub's GraphQL API, and I also take care of authorization in this step. So I simply pass in a GitHub token with the necessary access privileges that I need for this project, and the context manipulates every request before going out to that link and adds the header with the necessary token to it. Next up, I'm calling introspect schema to that link. Introspect schema will simply download the schema from the API and makes it available locally for me to manipulate. And then I'm making the schema executable. Making a schema executable in this case simply means any call to a query or type in this schema is deferred to this link. So it's simply passed along. And I can start my server, and I have a local proxy for my GitHub API that takes care of authentication already. Good first step, but not really what we need. ¿Por qué no los dos? We need two APIs to make a mashup. So we're simply doing the very same thing with Contentful. We're getting the executable schemas for both these APIs. And then we're merging them together. Merge schemas from GraphQL tools simply combines everything into one big schema, but intelligently remembers which query belongs to which API and delegates them correctly. At this point, things simply exist in one schema without any references between them. And again, I start my server. And this is what the schema looks like individually. We have a GitHub schema with the data from GitHub, and we have a Contentful schema with the data I store in Contentful. But that's a problem. If you noticed, these schemas conflict because they have the same name for the type. And every type, every query in a GraphQL schema has to be unique. So this won't do because I will only be able to query one of those two APIs, not both. Well, the great thing is the GraphQL spec is very well defined, and there's a defined abstract syntax tree underlying the schema, and I can use this abstract syntax tree to manipulate the schema programmatically. So this is a little bit more code involved. First off, I'm taking my Contentful schema, setting it up like I have before, and I'm passing it to transform schema. And now I can give it an array of transformations to make sure the schema is in a format that works for my use case. In this case, I want to rename all types that contain the word repository and simply replace them with repository metadata. I also need to take care of the top-level queries. Those are called root fields. And both APIs have a root field called repository. So I'm also renaming that one to repository metadata. And now my schema will look like this. I still have exactly the same schema from GitHub, but I modified the Contentful schema to rename every type, every query that has the word repository to be repository metadata. And GraphQL Tools is advanced enough that it will seamlessly still pass on the data to the right API, even though the type repository metadata does not exist in Contentful's GraphQL API. All right, time to get some stitches. So I have these two schemas, they're living in the same API, and I can query against them without having to know what the URL is. But the data isn't linked. I still need to actually stitch it up. And to do that, I need to write some new type definitions. I need to extend types of the existing schemas, or the one existing schema now, to actually build the links between objects. And for that, you can use the extend keyword that allows you to manipulate existing types. In this case, I'm adding a field Contentful metadata to GitHub's repository type. And I'm extending Contentful's repository metadata type with a field GitHub repository that contain the other object. So that's the schema, but I also need to write a resolver now again to actually resolve those fields for those objects. So let's first take the Contentful repository metadata object. I'm defining that the field GitHub repository on that object will be resolved by this function. The first thing we're adding is a fragment. A fragment is a small piece of reusable GraphQL query. In this case, I'm saying whenever you query for the GitHub repository field, add this fragment to the query. And this fragment queries for the GitHub name and GitHub login. That's necessary because I'm going to use these to then ask the GitHub API for this data. To ask for this data, I'm using merge info's delegate to schema. I'm simply instructing my server that the information the user is seeking lives in this other schema. So I'm delegating to it. And I'm delegating to it by querying the repository query with the GitHub login and GitHub name of the correct repository. This is the data I earlier got from my fragment. That's pretty easy. That's pretty straightforward. But what if it's not that straightforward? What if the APIs don't fit so neatly together? What if the data is not directly available in the format that I wanted to? What if there's not a clear query to just ask for this one piece of data that I need? Well, I have exactly that problem when I'm querying Contentful for data. Contentful has a little quirk in that you can only ask for a collection of objects. You can't ask for an individual object by one of its fields. So again, I'm defining a fragment that simply tells me I need the name and the owner's login, which is the organization name, whenever I query for Contentful metadata. And I'm delegating to a schema with a query. But as you can see, I'm actually querying for a collection. I'm not just querying for an individual object. And that's a problem because my schema says Contentful metadata will be an object, not a collection of objects. So how do I solve this? Well, when you delegate to a schema, you actually can add a new transformation to this query and the result you get back from that query. So I've done just that. And wrap query allows me to modify the query for repository metadata collection, to add a new level in between. Instead of just querying directly for the data, I'm querying for the items and then the data. And I'm modifying the result to simply return the first item of the first entry in the items array. So I got my schema stitched. I got my references between those two now. But there's more I can do with these tools. I can also infer new data. One of my favorite API endpoints in GitHub's API is the read a file from my GitHub repository and return it to the API endpoint. With REST, it was actually an endpoint. With GraphQL, it's just another field to query for. But what if I couldn't just read this data and then manipulate it in my API? What if I can actually take information contained in these files and expose it as fields in my modified GitHub API? So for this use case, I want to know, does this repository has a Travis CI YAML file? If it does, I can query Travis CI for the build set of this project. If it doesn't have it, I don't need to query. So I want to expand the type repository that comes from the GitHub GraphQL API, add a new field has Travis CI, and it's going to be a Boolean, and it's never going to be null. And then I write a resolver. First, I need to have the fragment. I'm querying GitHub object in the master branch for the file .travis.yaml, and it's supposed to treat it as a text blob. So it's a UTF-8 encoded string. And then I simply take that file and see if it exists. Let me show you how that works in action. Whoops. Let me switch to mirroring. It's always easier for demos. So I got my local GraphQL server working here. And Apollo server is pretty nice. It comes built in with the GraphQL playground that allows me to query for things. So let's start writing a query. We talked earlier about the repository endpoint, and the repository takes an owner, in this case Contentful, and a name. In this case, let's say contentful.js. And now I can ask for fields on that object. For example, the URL or the SSH URL. You see I get a very nice autocomplete, so it actually becomes fairly easy to figure out what name is there. There's the owner. The owner has some information like the login, for example. And when I query for that data, I simply get the result as JSON back. If I have a more complicated question about this API, I can also browse the schema here. And I see all the possible queries that are available on the GitHub API and on the Contentful API, because this is a stitch schema. So for example, the repository has also the information if it's a fork, for example. So let's ask for is fork. But much more interestingly for me, if I search for metadata, we have Contentful metadata as a field on the repository. So I can ask for Contentful metadata. I get, again, the GitHub name, which is a little redundant here. But I can also ask for information that GitHub doesn't know, namely which team owns this repository and has to make sure it's maintained. And I want to know what name that team has. I also want to know which of our development groups it belongs to. And maybe I also need to make sure which department is owning this. And you see it already takes a little bit longer because now it has to go to 2 APIs. But I get all the information about which team, which department owns this repository seamlessly in the same response as the information from GitHub about what this repository is. And I can, for example, also ask for the stargazers and see how popular this is. Our JavaScript SDK has 417 likes. Our PHP SDK, 63, for example, and apparently isn't owned by anybody. Now, the other cool thing is, remember the Travis YAML bit? I can ask, does this repository have unit tests on Travis CI? And indeed, it does. So, what I want to get is, stop treating your APIs as silos. They're not completely, they shouldn't be completely independent from each other. There are relationships that exist between them. And when you start exploiting these relationships, you can seamlessly access data across these APIs and make your developers' life much easier. And make some sweet music.